All right, let's talk about Java. But we're not going to just go through a boring list of rules. No, we're going to uncover its story. See, Java is all about a revolutionary way of thinking, a way to tackle really complex, real-world problems. So let's dive right in.
I mean, seriously, just think about it for a second. An app like Zomato. You've got restaurants, customers, delivery partners, menus, orders. It's a huge, messy system, right? How on earth do you translate all of that chaos into clean, manageable code? Well, that exact challenge is what led to a whole new way of programming.
So before we even type a single line of Java, we need a shift in our thinking, a new mental model. We've got to stop seeing code as just a long list of instructions. Instead, we need to start seeing the world as a community of actors or agents that get things done by, well, talking to each other.
This slide nails the concept perfectly. Think about it. When you're hungry, you don't need to know how Zomato's servers work or how they track a delivery partner. You just send a message, hey, I want a paneer butter masala. Zomato, as an agent, takes that message and says, got it, I'll handle it. It then sends its own messages to a restaurant agent and a delivery agent. The whole thing just works because these agents are passing messages back and forth.
And that right there, that whole idea has a name. It's called Object-Oriented Programming, or OOP. It's a way of designing software that lets us model our programs just like that Zomato example, as a community of interacting objects. Honestly, this whole approach was a complete game changer for building big, complicated applications.
So if OOP is this big, revolutionary way of thinking, then you're going to need a tool that was built specifically for it. And that perfect tool? Well, that's Java. Let's see how it came into being.
Let's rewind to the early 90s. A team at Sun Microsystems, led by the legendary James Gosling, was getting really frustrated with the old languages like C++. They needed something more reliable, more portable for all these new smart devices that were coming out. So they started something called the Green Project, and the result was a brand new language they first called Oak. A quick rename later, in 1995, Java was released to the world, and it pretty much changed everything.
So, what was the big deal? Why did Java get so popular so fast? Well, it was these core features. First, it was platform independent. This meant write once, run anywhere. Your code could work on a Windows PC, a Mac, a Linux machine, you name it, with no changes. It was built from day one to be object-oriented. It was also super robust because it managed memory for you, which got rid of a whole class of bugs. And, maybe most importantly, it was simple. It removed all the confusing, error-prone stuff like pointers that made languages like C++ such a headache.
Okay, so we've got the theory, and we've got the tool, Java. Now, how do we actually create those agents we keep talking about? How do we take an idea like a customer or a restaurant and turn it into something a computer can actually work with? Well, that's where classes and objects come in.
Now, this right here is one of the most fundamental concepts in all of Java, so listen up. A class is the blueprint. It's the idea of a car. It defines what all cars have, a color, a model, and things they can do, like start engine. But a class itself isn't a car you can drive. An object, on the other hand, is the actual car built from that blueprint. It's your Maruti Swift, with the color red and its own unique engine number. You can make thousands of different car objects from that single car class blueprint.
So, if objects are our agents, how do they actually act on the messages they get? They do it through methods. A method is just a fancy name for a block of code that performs a specific task. When you tell your Maruti Swift object to start engine, what you're really doing is calling its start engine method, which holds all the instructions for how to, start the engine.
Well, wait a minute. How does an object even come into existence in the first place? That's the job of a very special kind of method called a constructor. The moment you create a new Maruti Swift object, its constructor runs. It's the thing that actually constructs the object in memory and sets up its initial state, like setting its color to red and its current speed to 0.
And here's what that whole process looks like in actual code. It's basically a three-step dance. First, you declare it. You tell Java, hey, I'm going to have a variable that will hold a student object. Second, you instantiate it. Use the magic new keyword to actually create the object in the computer's memory. This is the moment it's born. And finally, you initialize it. The constructor runs automatically, sets up the object, and you assign this brand new object to your variable. Declare, instantiate, initialize. That's the whole process.
All right, so we get the big picture now. The agents, the blueprints, the methods. Now let's zoom all the way in and look at the basic tools we use to write the actual logic inside those methods. These are the absolute rock-solid fundamentals.
The most basic tool in your entire kit is the variable. Seriously, just think of it as a labeled box in memory where you can store one piece of information, like a student's age or their name. You give the box a name, you put some data in it, and you can come back and get that data anytime just by using its name. Simple as that.
Of course, those boxes, those variables, need to know what kind of data they're allowed to hold. That's where primitive data types come in. An int holds whole numbers. A double is for numbers with decimal points. A char holds just a single letter or symbol. And a Boolean holds a simple true or false value. And a really cool thing about Java is that these types have a fixed size everywhere, which is a huge part of what makes it so portable.
Okay, so having data is great. But what really makes a program smart is its ability to make decisions. And that's the job of control statements. The most famous one is if-else. It works exactly like it sounds. If some condition is true, do this thing. Else, do that other thing. This simple little structure is the foundation of all logic, letting your objects react differently to different situations.
So we've gone on quite a journey, huh? All the way from a massive real-world problem like Zomato down to the fundamental nuts and bolts of Java code. Let's just pull back for a second and tie it all together, because understanding this flow is the key to really thinking like a Java developer.
So, here are the key takeaways. First, at the highest level, you have the philosophy, object-oriented programming, which lets you manage crazy complexity. Then you have Java, the tool built specifically for that philosophy. That tool lets you create classes, which are the blueprints, and objects, which are the real things you work with. And finally, at the ground level, you build the behavior of those objects using your toolkit of variables and control statements. See how it all fits together?
The real power here is that this way of thinking lets you model literally anything. A banking system, a video game, a social network, they can all be broken down into a community of interacting objects. So the real question isn't just, how do I write Java code? The real question is, what problem do I want to solve? And that right there is the start of your real journey. Thanks for joining me.